So now let's go ahead and talk about strong and weak acids and see what the similarity between them is and the difference. So if we're looking at strong and weak acids, let's use a couple examples that we may be familiar with. So a strong acid, hydrochloric acid. Weak acid, maybe let's look at something that's similar, right? Has hydrogen and chlorine, HClO. Okay, and so we see that HCl is one of our strong acids, one of the acids that we know fully ionizes. And so we want to look at the difference between what a strong acid and a weak acid is. Okay, so we have a strong acid here, a weak acid, and what we know the main difference between these is that we get, for a strong acid, 100% ionization, whereas a weak acid, we only get partial ionization. And the reason why we would talk about this difference between partial and 100% is that we see that our weak acids undergo equilibrium in water when we add them to water. So like a hydrochloric acid, we take that, we drop it into water, and it's going to give us the hydronium ion and the chloride ion. Okay? And really important here, note, we write a single arrow this way, right? Saying that it's 100%, whatever amount of HCl I add into water is going to give us H3O plus and Cl minus. It exists as H3O plus and Cl minus in solution. Okay? Whereas if we're looking at something like this weak acid here, okay, and we have our weak acid here, we have HClO. It still has the same reaction that we're going to have. It's going to add to water and ionize and donate a proton to water to give us H3O plus and ClO minus. Okay, now note here, this undergoes an equilibrium, right? So we have the forward and reverse reaction. We would say we have 100% of our products here, whereas a weak acid, we only have a fairly small percentage is the product and a lot of the reactants. And so we'd say it undergoes this equilibrium. Well, if we talk about our equilibria, we talk about a Kc value. The Kc value for this specific reaction would be 3.0 times 10 to the minus 8. Now we're looking at a specific acid and the ionization reaction that it undergoes. We can also call this K sub A, and that would be for acid ionization. So this is the acid ionization for HClO, reacts with water, donates a proton, gives us H3O plus and ClO minus. So we see between a weak and strong acid, the main difference is that our weak acids undergo ionization, and only a small amount of it, that's why we call it weak, gives us H3O plus. Whereas a strong acid, all of it ionizes. All of the HCl we've added ionizes to give us H3O plus and Cl minus. And so we see because of this, this would give us a much more strong acid because we kind of look at the strength of an acid related to the amount of H3O plus that it can create in solution. And so we see, well, if I have 1 mole of HCl, I'm going to get 1 mole of H3O plus. Whereas if I have 1 mole of HClO dissolved in water, I'm not going to get 1 mole of H3O plus. Only a small percentage of it, right? If we look at a low or small Kc value, that means that we only get a small amount of products, lots of reactants. And so we see the majority of our acid here would be in the form of the molecular piece, HClO. Only a small amount of it would be in ClO minus and H3O plus. Only a small amount of it is ionized. And so we see the difference in trying to identify pH, trying to correlate the strength of these acids based upon how much H3O plus they give, has everything to do with a strong acid completely ionizes, whereas a weak acid only partially ionizes. And so in class, we're going to look at, well, how do we determine what the concentration of the ions would be, right? ClO or H3O plus or H3O plus and Cl, depending on the type of acid. So it's real important for us to look at that. We got to first broadly look at, is this a strong acid? Is it 100% ionized? Is it a weak acid? Does it partially ionize? And that's going to help us identify how we're going to look at things like pH, pOH, H3O plus concentration, etc. that helps us identify the strength of that acid in solution.